In this video, we're going to talk about logarithms and what those mean and how we can go back and forth between the two different forms here. Like you can see over here on the left, we have log base 5 of m equals x. We can use the b, the m, and the x to rewrite that to be b to the x power equals m. And just like that, we're going to use e, or a natural number, e to the x equals m. I can rewrite that to be the natural log of m equals x. All right. So if I use on the example one, if I use this rule right here, I'm going to use this top one, okay? And I'm just going to rewrite that. So the 2 is in the same spot as the b, so I'm going to put it as my new base. So I'm going to write a 2 right here. Then what I know is the 4 is in the same spot as the m, so I know that's going to equal m. So on the other side, I say equals 4. And then what I don't know, with my question mark here, we can use an x for that, but it's in the same spot as that x here. So I'm going to write it as my exponent that's on my 2. So now I have x. And now we can think to ourselves, 2 to what power gives me 4? And if you remember, we'll all know that x equals 2. So then I can come back and say that the log base 2 of 4, in fact, equals 2. All right. I want you to pause this video real quick. I want you to go over here and I want you to try this example here, and then we'll take a look at it. All right, now that you've had a chance to do it in the same way, we're going to take this 3, we're going to make it our new base. This unknown or x value is going to be my new exponent, and then the 27 is going to be equals 27 on the right side there, and then you have to think to yourself, 3 to what power gives me 27? And we know that to be x equals 3. So we know that the log base 3 of 27 equals 3. All right, now let me show you real quick just basically the same thing, but I want a slightly different way to think about it. So the log is basically the undo operation for exponents. That's why we have it. It helps us solve exponential equations, which we'll do in a later video. But if I take my log here, log base 2, and if I make 2 the base of both sides, okay, so this unknown, we'll call this question mark an x right here. What happens here on the left side is this 2 to the log of 2 essentially undoes itself, right? It's the opposite operation, so it just essentially cancels it out. So all you're left with is a 4 on the left side, and now on the right side we have 2 to the x, which is exactly what we got before. But I wanted to show you that because, again, it's a slightly different way to think about it. Same thing over in that other example. If I take a 3 and I make a 3 the base of both sides and turn my left side and right side into the exponent, you'll start to see the same thing happen. The log base 3 and the 3, those are opposite operations of each other. It undoes itself. So I'm left with a 27 over on the left side, and on the right side I'm left with 3 to the unknown, which we said was an x. And again, essentially we got the exact same spot that we got last time, just a slightly different way to think about it. All right. Now we could do a very similar thing down here with the log base 3 equals -4. All right, it's a little bit different order here, but I still know that the 3 is going to be the base, so I have 3 here, and I know this -4 over here is going to be my exponent, and that equals some unknown value. I know that is going to be 3 to the -4 is going to be 1 over 3 to the 4, which I know 3 to the 4th power is 81. So x in this case equals 1 over 81. All right. Now then, I want you to pause the video over here to the right side, and I want you to do this example here. Log base 1/2 of x equals 8. All right, now that you've had a chance to try that on your own, we're going to do this together. I know the base here is 1/2, right? And the 8 is going to be my exponent, and that's going to equal x. So 1/2 to the 8th power is 1/2 times itself 8 times, which is going to equal 1 over 256 equals x. Okay. All right. Now I want to show you a slightly different way to think about it, similar to what we did earlier. All right, I'm going to think of it as undoing the operations. Because I have a 3 as my log base, I'm going to make the 3 the base on both sides. Again, the 3 and the log base 3 are opposite operations, so they cancel each other out. So I got x equals 3 to the -4th. And again, it's the exact same spot we were last time. And same thing here. I'm going to make 1/2 the base, and what I originally had in my equation is the exponent for either side. Again, the 1/2 and the log base 1/2 are opposite operations. cancel each other out, and I have x equals 1/2 to the 8th power. And again, we're in the exact same spot as we were the last time. Okay? All right, so now we'll show you one more example where we have the e, or the natural number. I'm going to use the same exact thought process here, but now the opposite operation for e is going to be the natural log here. Okay? So what I can do is I can think about it in two ways. I can follow my rule here, right? I can take my exponent, put it over here by itself, and I take my m value, and I can take the natural log of that m value. All right, so I can say the natural log of 4 equals x. All right, that's one way to think of it. And again, when we get to this point here, we're going to use the calculator to help us out. We're going to type that in because that'll give us the decimal, because we know that e is that irrational number 2.718. Or we'll think about it like this. I would know the opposite operation for e, the natural number, is the natural log. So if I took the natural log of both sides, the e and the natural log are opposite operations, and all I'm left with is x on the left side, which equals the natural log of 4. As you can see, either way, I get to the exact same spot. Okay, it's just a slightly different way to think about that, but we're doing the exact same thing. Okay, so these rules right here are going to be exceptionally important to memorize and to be able to go back and forth. Again, you can just memorize the rule and just do the conversion every time, or you can understand the opposite operations and how those work and how we can use those to cancel the logs out and the natural logs and the natural number e out. And then we're going to use these later in word problem applications. Make sure that you write those down, put them in a spot you're going to remember them, and memorize those. All right, hope this video helps. We'll see you in the next one.